47. How long would it take to reduce 1 mole of each of the following ions using the current indicated? So in this case, we have a gold ion. We have Au3+, with its current of 3.57 amps or ampere. So we just stated that anytime that you see a capital A, that's amps or ampere, and that's the type of current. But just know that in our chemistry formulas, we will see a current as a capital I. So you won't see it as capital C, nor capital A. I is always the variable in the formula. So I have an I value here, and they're asking for how long will something take, right? If you're asking for something for how long it's going to take, that's always a time value. So I'm looking for time. They gave me a mole, so I'm kind of have an N value as well. So I say to myself, what is the formula that links moles with I's and T's? And that's the formula here. Now I just rearranged it just to get T equals, but you could have arranged this formula to get your N, which is your moles, and your current, which is your I value. So we're going to plug in for your I value, right? That's the current. So that's 3.57 amps. So that's all taken care of. F is Faraday's constant, which is a constant number. So that's a given. 96,485. If you want to know the units, it's just coulombs per mole. And now the N value is a little bit tricky here because when we're talking about electrolysis or, current, redox reactions, reduction, oxidation, cathode, anode, the N goes a little bit farther by just saying 1 mole. It's the moles of electrons that are being used. But the only thing that they gave us was that I had 1 mole of the ion. That is not the same as the moles of electrons. So in your 1 mole of Au3+, we have to find out how many electrons are being used. And that's in the upper right-hand corner. What does a 3+ mean? Well, a plus means that we lost electrons, but how many? Yeah, you got it. 3. 3 electrons was lost for every 1 mole of gold. So now I know 3 electrons were being used. That's my N value. So I know that my N is a 3. And now since I have all of the values, let's just plug it in. Okay, so I'm going to start off with my Faraday's constant, 96,485. The current was 3.57, and the number of moles was 3. So 3 times 96,485 divided by 3.57, and that looks good. So I have a time of how many sig figs? 3 sig figs here. So 8.11, because I got to round, times 10 to the 1, 2, 3, 4. And just know when you're using this formula, the time is always going to come out in seconds. So there you go. They did not specify what unit they wanted it. They just said how long. So technically this is a good enough answer, but just know that if you wanted to go to minutes, you just need to divide by 60. And then if you wanted to go to hours, you just divide by 60 as well. So if I just take the answer divided by 60, this is the amount of minutes that you're looking at, 1,350, somewhat around there. And then if you just divide by 60 again, you're looking roughly at 22.5 hours. So almost 1 day. That's a long time. And that is your answer. Hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you want to help us out. Tell your friends, tell your classmates about this cool channel. I think it's pretty cool. What do you think? Talk to you soon, and I hope you're having a great day. Bye-bye.